you can see the figure, helical reinforcement needed where the column is circular, and for circular column we need minimum 6 number of member, mean longitudinal bar. Okay, and the tie bars are spiral here. If you see longitudinal section, you can see the tie bar are spiral here. Okay, that's why this is called helical reinforcement. Okay, so that means this kind of arrangement actually called helical reinforcement. Before read it out, let's check the IS code consideration. For helical reinforcement, IS code consideration is given in clause number 39.4 of IS 456/2000. Let's check it out. As per clause number 39.4, as you can see here, compression member with helical reinforcement. The strength of compression members with helical reinforcement satisfying the requirement of clause number 39.4.1 shall be taken as 1.05 times the strength of similar member with lateral ties. So that means for helical reinforcement we have to multiply 1.05 with this formula. Pu is equals to 0.4 FCK AC plus 0.67 Fy ASC. So we have to multiply 1.05 with this. Okay. Now, as per clause number 39.4.1, the ratio of the volume of helical reinforcement to the volume of the core shall not be less than 0.36 into Ag by Ac minus 1 into FCK by Fy. Now, where Ag is gross area of the section and AC sometimes in somewhere it may be taken as AK, AC or AK is area of the core of helical reinforced column measured to the outside diameter of the helix. FCK is characteristic compressive strength of the concrete and Fy is characteristic strength of the helical reinforcement, but remember not exceeding 450 Newton per millimeter square. Okay, so let's check the notes. So the strength of a column with helical reinforcement is calculated as following as per the clause number 39.4. Pu is equals to 1.05 into 0.4 FCK AC plus 0.67 Fy AC, as I said earlier. Now, columns with helical reinforcement or spiral are more ductile and have improved strength. Thus, their load carrying capacity is more than that of the columns with lateral ties. Okay. As per IS 456/2000, the shape load of for columns with helical reinforcement is 1.05 times the safe load carried by a similar column with lateral ties, provided the requirements given below are fulfilled, which we read out in code also. The ratio of the volume of helical reinforcement to the volume of the core shall not be less than 0.36 into Ag by Ak minus 1 into Fck by Fy. In right side you can see the diagram. This is a cross sectional diagram of a circular column or a column with helical reinforcement. You can see the core diameter here, and main bar and spiral bars are also denoted. Core diameter is denoted by D suffix C and hole diameter is denoted by capital D. Okay. Now, as per the as per the consideration which is written in clause number 39.4.1, volume of helical reinforcement by volume of core should be greater than 0.36 into Ag by Ak minus 1 into Fck by Fy. Now Ag is cross sectional area of column, so it will be pi by 4 into capital G square, that is whole diameter square for a circular column. Ak or Ac, whatever you want you can write. Area of the core of helically reinforced column measured to the outside diameter of helix. Okay. So it measured to the outside diameter. Okay. Fck is characteristic compressive strength of concrete. Fy is characteristic strength of helical reinforcement but not exceeding 450 Newton per millimeter square, as we read earlier. Phi is diameter of spiral, and small p is pitch of spiral. Okay, pitch means the center to center distance. Okay, now Ag is equals to pi, so that's why Ag is equals to pi by 4 d square. Ak is equals to pi by 4 dc square. Now dc, diameter of core, whole diameter minus 2 into end cover. Okay, because there are in two sides there are there is cover. D dashed means the inner core diameter, that is equals to d minus 2 into end cover minus phi s, that means diameter of spiral. This is how we can find out the inner diameter of the core. So outer diameter of the core is dc and inner diameter of the core is d dashed. Volume of helical reinforcement per mm height of column is equals to circumference of spiral into area of spiral by pitch of spiral. So that is equals to pi into d dashed into pi by 4 into phi square by p. Okay. Circumference of spiral is pi into d dashed and area of spiral is pi by 4 into phi square. Okay, and pitch is p. Volume of core per mm height of column is pi by 4 into dc square into 1. And steps are for designing is same as lateral dies, which we cover in previous lecture. So let's solve a problem that will help you to understand better these assumptions. Okay. So this is the problem in your screen. Design a circular column of diameter 400 mm subjected to a load of 1200 kilonewton. The column is having spiral ties. The column is 3 meter long and is effectively held in position at both ends but not restrained against rotation. Use M25 concrete and Fe415 steel. So this is the problem of helical reinforcement. We have to design a circular column with helical reinforcement. End conditions are given here. Okay. So what is given in question? The length of column capital L, that is 3 meter. Axial load P, capital P, is 1200 kilonewton. Diameter capital D is 400 mm. FCK is 25 Newton per millimeter square for M25 concrete and Fy is 415 Newton per millimeter square for Fe415 steel. So first of all we have to find out effective length. So LEF, effective length for the condition column is effectively held in position at both ends but not restrained against rotation. Let's check it out. Table number 28 of IS 456-2000. Now in table number 28 of IS 456-2000 we have to find out our end condition. So you can see in extreme left column number 3 is our end condition. as per the problem, effectively held in position at both ends but not restrained against rotation. Look, symbol is also given. Okay. So recommended value of effective length is 1L. So we should take this. So effective length is 1L, then so slenderness ratio is equals to L by D.